So the first set of products we will review today is the Seahawk leak detection. Why? Because leaks happen. Unfortunately, with the age of today's current infrastructure, leak detection ought to be considered almost everywhere. Data centers is a big critical space. Hospitals with all the MOBs and ORs. I've done some jobs where we've put leak detection that had drain pipes that were literally over multi-million-dollar machines. Medical records. You have high rises that might be 20 plus stories tall. The big elevator shaft in the middle. One, the hydraulics on the bottom, and two, there might be some different plumbing around the bathrooms that are going down. Might be some electrical power or even datacom that follows that shaft. Schools are older buildings, generally speaking, and have a lot of the older piping out there. Hotels. Imagine how many hotels out there have rooms with piping, especially some of the age of those hotels. Love to work with them. Different commercial buildings as well as airports, the long stretches of piping that goes all throughout them. So I know that's not the full list, but that's certainly a great place to start, as I believe we have a way to help solve some of the proactive approach to resolve catastrophes resolve problems before they become a catastrophe. So the question that usually gets asked is, how do we get started? I would say you can get our checklist here, risk mitigation checklist, off of our website, or contact your local partner. But it's really starting to identify the threats and their sources. Is plumbing in the walls? Is there faulty fittings? Is there valves? Have you had problems with it? What's the age? Are there uncapped sprinkler heads? Could there be clogged drains? What happens? Leaky roofs, small drip pans, and then start to look at, well, where does it go and what happens if it does go, right? So are we looking at a drip pan type solution where a spot detector could work? Or are we looking at something where it may require some sensing cable and a longer range of sensing options? The spot detectors really are designed to be used inside of confined areas to detect conductive fluids. Can be put in series with other sensing cable options. There's a relay option that you can bring in directly to your controller, or you can bring in some of these other options directly into our controllers as well. So the versatility is pretty nice. And they're also potted, so once they get wet, you can shake them out and use them again. You don't have to necessarily throw them away like some of the other options in the market. The sensing cables are a patented design that helps eliminate false alarms. There's a thread around the two wires that wrap around the orange cable or other colors based on the different designs that are available. And they're plenum rated CL2P as well as a quick dry reset. So the standard cable is an orange conductive cable. The green cable is a chemical cable, still looking for a conductive fluid, though they are much more resistant to harsh environments. And then our rodent resistant and zero halogen cables are also available based on the different environments that you may be putting them in. The purpose of the leak detection is to detect fluids. Could be under chilled water supply and return lines, could be under raised floors, could be any other critical application where you're trying to protect your assets. Monitor, integrate, alert, provide peace of mind. That's why we exist. So the purpose of a zone controller is really to identify a fluid leak in a space that it shouldn't be, in a particular zone. So the LD310 on the left can handle up to 300 feet of sensing cable, has an audible, visual, as well as a relay closure. The LD1000 next to it can handle up to 1,000 feet of sensing cable. Again, the audible, visual, as well as the relay closure, but then also can integrate via Modbus RTU. The guy in the middle is an LD-RA6, which is a 6-zone leak detection, so each zone would have their independent alarm notification, and can also talk Modbus RTU. The guy just to the second to the right there is part of our Raptor line, which is a 3-zone leak detection. Communication can be MSTP BACnet or Modbus RTU, selectable on the controller, identifying 3 zones of leak detection, integrating into a building automation platform. And then the guy on the right is super intelligent as far as zone control goes, because it not only does the leak detection, but it also has 4 auto discover temp probes that we can integrate with that, auto discovered into the user interface that's supplied inside of that device. It also has 8 digital inputs, has the capability to bring in some IP connections, could be cameras that you may want to bring in to create a single pane of view. But then the alarm capabilities could be Modbus IP. Again, it's got a user interface and software built into it, so the ease of setup is mind-blowing how simple it is, quite honestly. And for all of the different applications above and beyond the simple leak detection, certainly has a platform and fit inside of building automation. So moving on from the standard zone detection, there is a distance read leak controller that we've brought to the market, which identifies the location at which a fluid comes in contact with the spot detectors or sensing cables. There's 2.8 ohms that run through the cable, giving it a little bit of an electric charge, which allows us to identify where along that run a leak was detected. The variety of different controllers that exist inside of this space is the Seahawk 10K, the LD1500, the LD2100, and the LD5200. As you can see, there's a variety of different max sensing cable lengths available, all the way up to the LD5200, which will do 10,000 feet of sensing cable. Also has the ability to integrate up to 10 maps. There's an audible, there's a web user interface. It does direct email notification. You can create virtual and physical zones. That guy does also talk SNMP, Modbus, N2, and BACnet. And then the relay outputs on there is 2 for leak and 2 for fault. So there's a variety of different options on there that really help that to be such a robust system. So now, after you've decided which controller makes the most sense for your needs, it's coming down to design now, right? So there's a variety of different accessories that you can load into a bill of materials to ensure that you're getting the coverage needed. There's non-sensing cable, a variety of lengths. So you can see there's connectors on the end that literally connect in a second with a snap of a twist of a nut. There is different X connector options. So when you're coming into a zone and want to split out to another floor or another area, the guy in the middle there is called an X connector, which allows you to architecturally fit some of the different design options that exist. On the right there, it's called a weighted cable connector. Generally used when you're putting in series non-sensing cable, sensing cable, non-sensing cable, and sensing cable to make sure that you're getting a verified simulated resistance, so that if it did fall on the sensing cable on the first leg, within reason, that non-sensing cable is not counting towards the overall sensing length. So to ensure that from one zone to the next, in between the extensions, you may consider putting in a couple of these weighted cable connectors. There's different enclosures. There's the J-clips that secure it to the floor, as well as caution tags. Obviously, whenever you're doing your distance read leak, you're going to want to note where all of those exist and at what zone, and have names for them. And then something we also like to put together for our partners and end users as well is a framed reference map. So this would help to identify where the leak is and when it occurs on a nice little map that sits next to the controller, but that then also can be integrated into the overall control system, so that when it does get a leak, you get a blinky dot to let you know exactly where that is. Here's an example of one of the integrated maps for the distance read leak layouts. If you notice on the bottom in the middle, there is the LD5200 with the blue wire coming out of it, leading up to an X connector, which then splits out in 3 different directions. So that's a good example of how an X connector can be used. Each leg is also going to have 50 feet of simulated resistance. So again, we're isolating which areas and directions everything's going, so that you ensure that when a leak does occur, you're sending the appropriate maintenance personnel to the proper area without any question of knowing where it originated. And then when you go through all of the commissioning process, as you put a damp rag along the sensing cable, you're going to go ahead and identify different distances that all get recorded into that commissioning and programming process. So now here is an example of what a distance read leak controller will look like when it alarms.
For more information, please contact your local Cochrane office.